Hello, thank you for checking out A1 Math, and today I'm going over exponential functions, and I'm going to talk about how to write a function, how to graph a function, and how to work out some word problems. So let's begin. So in this first problem we have here, it says, suppose an investment of $2,300 doubles in value every decade. How much is the investment worth after 2 decades? So what we want to do is start with this function here. The base is y equals ab raised to the x. And we have to find two things, the a and the b, to write the equation. Once we write the equation, we can plug in the x to find out what y is. So the A is where you begin, and the B is what happens every decade to where you begin at. So where you begin at $2,300. So that's going to be your A. And what happens to that? It's being doubled. Okay, so you're going to take that and you're going to multiply the A times the B raised to a certain exponent. So doubles mean it is times 2. Okay, so now we're going to write the function with our a and b. So we have y is equal to a, which is 2,300, and b, which is 2, and raised to the x. But we know what the x is on this, so we're doing more than just writing the equation. We're going to figure out what happens in 2 decades. So we do that by plugging that in. Take the x and raise it to, take the 2 and raise it to whatever our x is, which is in 2 decades. And then you take that and type it in the calculator like so. It'll say 2,300 times 2, raise it to the second, and hit equal. And then y is 9,200. So that's what it's going to be in 2 decades. Okay, let's take a look at another problem. Okay, in this problem, it gives us a table. And what we want to do is take the table. We want to use the information to predict the number of termites in a termite colony after 1 year. Okay, so we take a look and see how they give it to us. They give it to us in months. So 1 year is another word for 12 months. That's first and foremost. All right, so really want to know what happens in 12 months because the time is given in months. Okay, now we're going to take this information and understand that it's a geometric sequence. Okay, if you take 200 and divide it by 100, you get 2. You take 400 divided by 200, you get 2. So I'm going to write that out. This is how we find our common difference. So our common difference, it's called common difference, but let me go ahead and use what we have for our formula, which is b. So we got y is equal to a b raised to the x. So that common difference is b. So you get that by doing 200 divided by 100. And when we do, we get 2. So now we could find out, similar to what we did in the previous problem, we could find out what's going to be in 12 months by plugging in 12 for our x. But we need to know what a is. We don't know where we begin at. So that's what we're going to find out. So to do that, what we could do is take this as 2 points. One point being 1 and 100, the other point being 2 and 200. Okay, and we already got the common difference. We're gonna pick one of these points and plug it in here and solve for a. So let's take the easiest one, which is 1 and 100. So for y, and this would be x, and this is y over here. So for, let me write it right here, x and y. So for x, we got 1, and for y, we got 100. So plugging in y, I got 100 is equal to a, I don't know, times b, which is 2, raised to my x, which is 1. And I'm just going to solve for this. So that I got 100 is equal to a times 2 to the 1, which is 2. And now to solve for a, I just divide by 2 on both sides, and a is equal to 50. So I know what a is. A is 50. Now I'm going to plug it back into the y equals abx. So y is equal to a, which is 50, times b, which is 2, raised to the x. Now I'm going to do the same thing I did before. Now that I know the a and I got the formula written, what I'm going to do is go ahead and put in 12 and figure out what I get. So I would type y is equal to 50 times 2 raised to the 12. And I would type that in the calculator. 50 times 2 raised to the x, which in this case is 12. Okay, and I get 204,800. So that's how many termites is going to be in 1 year. That's a pretty steep jump there. Okay, let's take a look at another problem. Okay, so all right, this is number 9. Now, number 9, what we want to do is graph, and we want to figure out how this graph is going to look, and we want to be able to graph it and talk about the end behavior. So to do that, I'm gonna set up a t-chart. I'm gonna have my x and I have my y, and then for x, I'm gonna use -1, 0, 1, and 2. And then what I'm gonna do is plug in each value into the calculator. So I have -3, and then 0.6, close parentheses, and raise it to this 1, this -1. So that's going to be -1. Oh, and that's going to give me -5. And then if I go back, get rid of the -1, and put in 0, that's going to get me -3. And if I go back, get rid of the 0, and plug in 1, that's going to get me -9/5, which is, let's see if this come out right. Nope, it's 1.8. It's going to be 1.8. And if I take this out, put in 2, I get this, which is 1.08. So I'm going to write those numbers in. -5, -3, -1.8, and -1.08. All right, so we start way down here at -5. So I go -1 down to -5 to make a point. Then at 0, I go to -3 and make a point. And at -1.8, that's almost 2. So I'm going to come about right here and make a point. And -1.08 is almost 1. So I'm going to come here and make a point. And as you can tell, the line's going to go, keep going, keep going, keep going, keep going, like so. Okay, so there's a few things here we know. We know that A is going to be -3. B is going to be 0.6. The y-intercept is 0, -3. That's where it crosses the y-axis. And now we just want to talk about the end behavior. So as x goes to positive infinity, what does y do? and as x goes to negative infinity, what does y do? So as we go this way, pull this up here, as we go this way, what happens is y goes to, keeps getting closer and closer to this line, which means it's going to 0. So as x goes to negative infinity, I'm sorry, positive infinity, y goes to 0. Now, as x goes this way, this keeps going down. So that's going to negative infinity. So as x goes to the left, negative infinity, y goes to positive infinity. So that's just a few things I'm covering. It's going to be on the next test. For now, just want to thank you for checking out A1 Math and have a nice day.